Hi students, welcome back. Today we are going to discuss about the clustering validation and clustering concept. The clustering of validation, the main purpose of using this concept, it is used to find the good clustering for a partition from a data set which is considered for our problem to solve it. Then for partitioning and validations, it uses some of the algorithms. Okay, and the quality of the partitions, it is evaluated through three tasks. The first task is classification task, second one is the predictive task, and third one is the clustering task. The clustering task, again, it is subdivided into two categories: automatic, and the second one is the using expert input. Through this we can evaluate the our partitions. The first one is the classification task. Classification task, mainly it is used for the identifying the best cluster algorithm. Classification purpose, we will use the algorithms, right? For while you are before you are using this algorithm, we will identify the which one is best and which one is suitable for our problem. And the second one is predictive task. This predictive task, it should have a clear meaning. Through that clear meaning only we can take the decisions. Okay. And also this will be having a clear meaning with the classify objects, and this will not be suitable for the cluster partitioning. Okay. Understand? It is not suitable for the cluster partitioning, but it is only suitable for the classification of objects. Then the next one is the clustering task. The clustering task, it is used for the validation measures. And for validation measures, it will consider only the numerical measures. That numerical measures, it is used to make a judgment on a particular aspects. And the cluster validity is evaluated by through this two methods, automatic and using expert input. First, we will go with the automatic measures. While we are going with the automatic measures, it is categorized into three types: external indices, internal indices, and relative indices. The external indices is nothing but we are getting a input from the expert members or external members, and through that we will define a cluster quality. And while we are defining a cluster quality, it should go with the two common measures: correct R&D and Jaccard. These two measures, which is used to evaluate the external indices. And the next one is the internal indices. The internal indices, it is used to measure the goodness of a clustering structure, and also it will ensure the compactness and separation of two clusters. Then here it will use the two common measures in internal indices: Silhouette index, and next one is the sum of squares. The Silhouette index, this will be used to measure the compactness and separation of a cluster objects, and the sum of the square, it will be used to measure only the compactness of a object in a cluster. Then next one is the relative indices. The relative indices, this will be used to ensure or measure the relationship between the two clusters. The clusters, it will be considered based on the usage of the same clustering techniques are running on a same algorithms. So this is the concept of relative indices. Then Silhouette index, internal index, is the concept measuring index common measures which is fall under the internal indices. This will be used for evaluating the compactness inside the cluster. And while we are evaluating, it will consider the two cases: how the each and every object in a cluster are closer. Then next one will be the separation of a different cluster. How for the object is having a cluster measures, that is a relationship between one cluster with the another cluster. And this is the equation to calculate the Silhouette internal index. we are considered the index as x of I for Silhouette, and thus 1 minus a of xi divided by b of xi. Usually for while we are forming a cluster, it will follow the index values as +1, 0, -1. Based on this only it will form a cluster. If the given while we are forming a cluster, if it is a positive value, then definitely the A cluster must be greater than the B of xi. If both are equal, then it will be represented as 0, that is, it will be placed in the same group. And if it is a -1, if A of xi is greater than B of xi, then that will be placed in a one group. The next one is within a group of some squares. Then this will be used for only measuring the compactness of a cluster. And here it will use the Euclidean distance between the instance and centroid. For that we will use the equation sum of squared Euclidean P of P comma Q. P comma Q is the indices, and the K of 1 to M Pk minus Qk whole square. Okay. This is the actual general term sum of squared index equations. And if you want to find out the measures within a group or sum of squares, then that will be represented as sum of squared equal to summation of I equal to 1 to the power of k, j equal to 1, j of I, then square of Euclidean p of pj comma ci. In this, the k is the number of cluster and the ji is the number of instances of cluster I, and the ci is the centroid of cluster I. Okay. Basically, this equation it is used for calculating the sum of squares. The next one is the Jacob external measures. This is one kind of measures which is available under the external indices. Then this will be used to monitor the variation of a similar measures which is used in a classification task. And it will be evaluate the based on the uniform distribution of objects within a cluster. That too, it is related to the class labels. Then the formula to calculate the Jacob is J equal to M of 1, 1 divided by M of 0, 1, 1, 0, 1, 1. Okay. Where in this M01 is the number of objects in other cluster but with the same label, and 10 number of objects in the same cluster but with different labels. 00 means objects with the other clusters different labels. 11 is the number of objects in the same cluster with same label. Okay, this is your reference, and thank you guys.